Let's dive right in. Today, I'm joined by two fantastic Shure experts, Jason Waffle and Sergio Alvarez, and they're going to take us through all the ins and outs of Axient Digital PSM. And we're going to start by kind of just talking about the platform itself. Then we'll be diving into transmission modes, spatial diversity, internal antenna combining. We'll take a closer look at those operational presets, and then we will get into that Q&A. So without further ado, let's get into it. Take it away, gentlemen.
Thanks so much, Cheryl. Appreciate it. So to start, I just want to give a brief introduction to Axient Digital PSM and the overview of this brand new product that we are very excited to launch. We are incredibly thrilled to finally bring the Axient Digital franchise to the PSM franchise and bring in-ear monitoring into the digital age. Just a few bullet points, high-level overview of what Axient Digital PSM brings. We're adding superior digital RF performance to PSM for the first time ever, so we're very excited about that. This comes along with exceptional audio quality and digital audio inputs, so Dante AES3, AES67, as well as analog. We've really built this box to be somewhat of a Swiss Army knife of RF, as I like to call it, and that's what most of today is going to be about. So we're looking at some future-proof transmission modes that does include Shure's first WMAS product. They are wide tuning, so significantly wider than our previous band splits for PSM 1000. And obviously, they are fully integrated with our management software suite, including ShowLink and Wireless Workbench. That's going to pretty much round out our top-level overview of PSM 1000. I'm going to hand this over to Sergio, who is going to spend the next 40 minutes or so, maybe less, diving deep into the woods of everything that this product can do from an operational preset side. Sergio?
All right. Hi, everybody. Again, my name is Sergio Alvarez, and I am a product manager at Shure. I'm going to go ahead and dive into this. What is an operational preset, right? I would say the operational preset is kind of the first thing you want to configure for your Axient Digital PSM system, right? And what it really is a device level configuration, right? That serves as this umbrella for the combination of 3 RF parameters, right? Again, this setting is critical for optimizing performance based on the features that would benefit yourself across various environments, right? So what are these 3 RF parameters, right? First is the transmission mode, right? And we'll kind of get to what those options are. Whether or not spatial diversity is enabled, and this is a new feature that we'll talk about that is that is possible with the digital wireless domain. And then internal antenna combining. For the first time, these transmitters, if the transmitter is sending multiple frequencies, the transmitter itself can serve as a combiner and actually combine that RF for you. It can reduce cables and kind of reduce the number of external combiners you might need. So what else should I know about operational presets? Again, right, this is something you want to choose at the time of setup, right? Operational presets aren't designed to change dynamically during a middle of performance, right? I would describe operational presets almost like a choose your flavor of product, right? It's almost like 8 different products combined into one, right? And we let you, this is the amount of flexibility is part of the benefit of Axient Digital PSM. So again, choose at the time of setup and be aware that, anytime you change the operational preset, the system is like, oh, okay, I'm just starting over, right? So it's going to kind of erase any previous ADXR body pack receiver registrations, right? So what you want to avoid is, doing a lot of the labor of setting up your linking registered portables and choosing the operational preset before you do all of that work, right? So just something to keep in mind. All right, so let's get into, again, let's dive deeper into the 3 RF parameters that I was talking about that is under the operational preset umbrella, right? So over this presentation, I'm going to be talking about 4 different transmission modes. The first transmission mode is what we're calling multi-channel wideband. To explain what multi-channel wideband is, first I'm going to explain the concept of WMAS, which is something that's kind of new in the field of digital wireless. And so what WMAS is really just a new regulatory framework that allows us to go beyond the traditional 200 kilohertz RF carrier, right? Every wireless product in the past has operated under this paradigm where, one user requires its own dedicated RF carrier. Then you have a bunch of these RF carriers in the air. They all each produce some amount of intermods, and you have to kind of RF coordinate for all of that, right? With WMAS, our approach to WMAS is really kind of squeezing multiple of these RF carriers together into one single frequency, right? And that allows us to do cool things in terms of spectral efficiency. So if you go on to the next slide, with Axient Digital PSM, we're offering different flavors of WMAS RF carrier sizes, right? The quad transmitter will offer support for up to 4 stereo audio channels inside of 800 kilohertz RF carrier, right? So it's kind of like, again, I'm squeezing 4 200 kilohertz carrier straight into one RF carrier that's 4 times the size of 200 kilohertz, right? And that allows us to do a couple of things, right? It cleans up the intermods, right? Because now all of a sudden you only have to worry about the intermods outside of the slightly larger RF carrier. It reduces the number of RF carriers in the air, right? So there's less frequencies to coordinate, which hopefully will make things a little bit simpler from a setup standpoint. And then the other thing to note, right, the dual transmitter is essentially a 2-channel wideband carrier that's 400 kilohertz wide. And then as you can see, right, what does this do for spectral efficiency, right? With this new 4-channel wideband carrier, you can actually place them directly next to each other, right? Because the intermods are so buried in the noise floor that intermods is much less of a concern with WMAS carriers, right? And so with each 4 channels occupying only 800 kilohertz that has the same 800 kilohertz channel to channel spacing, we can support up to 28 stereo channels in a 6 megahertz TV band, right? And for the broadcast folks, right, that's stereo. So that means like up to 56 channels of mono with 4-channel wideband with Axient Digital PSM. This is just an example of like what that might look like in the spectrum, right? So as you can see, that middle block is channel 17, and we're able to successfully put 7 of these frequencies that support a total of 28 stereo audio channels. So let's review the benefits of multi-channel wideband, right? You achieve greater spectral efficiency, right, with up to 28 channels per 6 megahertz, cleaner noise floor, which not only helps the PSM, but it also helps all the other wireless that's on the field, including your wireless microphones, right? When you have less intermods produced on air, you have more room for your ears, for your mics, and everything else that might be on air. It provides easier frequency coordination because you're reducing the number of frequencies that you need to coordinate. And then the other thing I'll mention, right, this is one of 2 transmission modes that are digital wireless, right? And so the latency here is less than 2.9 milliseconds, right? And that's across the board for any digital transmission mode. Right. So ultimately, with this greater amount of spectral efficiency, RF engineers are able to say yes to more complex productions and live events. What else should I know about WMAS and multi-channel wideband, right? One thing that's kind of new is this concept of shared RF output power, right? When you have multiple users on a single RF carrier, right, that RF carrier has a total amount of power, right? Just to use round numbers, right? In this case, the actual RF output powers is kind of a topic I definitely want to cover maybe in a future webinar. But ultimately, for this presentation, right, it all depends on your region, your device, which operational preset you're using. We do plan to provide further documentation on those specs, so stay tuned for that. But just to use round numbers here, right? Let's just say it's 100 milliwatts per carrier, right? So for a 4-channel wideband carrier, each individual sub-channel, right, would effectively operate at 25 milliwatts per channel, right? With the dual, given that there's only 2 users it's supporting, right, that same total power of 100 milliwatts would only get divided by 2 for a net output of 50 milliwatts per channel. So that's just something to keep in mind. That's just inherent in WMAS technology. And this is something that we will provide transparently in a feature that we call RF system gain. So this is completely viewable on a per antenna port basis, right? So that's just something to keep in mind, right? And this is something that narrowband doesn't have to worry about, right? Narrowband doesn't share RF output power. So depending on your total distance need, especially in terms of like outside line of sight applications, narrowband might be something that you prefer. And what's unique about Axient Digital PSM is that we are offering both WMAS modes and traditional narrowband modes. So speaking of narrowband, right? Why would you potentially choose narrowband, right? Access to more RF output power, right? Especially for those greater line of sight distances. This kind of adheres to the previous narrowband rules of 200 kilohertz per carrier. It can fit into tighter spaces of open spectrum, right? Like if you're trying to maximize every bit of RF that's available, right? Having potentially a mixed inventory of wideband and narrowband could help you out in terms of using as much of spectrum as you possibly can, right? In terms of spectrum efficiency, right, this is nothing to scoff at, right? We're essentially offering the same amount of spectral efficiency as our Axient digital microphones of up to 17 channels per 6 megahertz. And that's particularly impressive because we're essentially doubling the amount of audio information with this being stereo audio, right? So again, narrowband adds flexibility when navigating challenging and unpredictable RF environments. Again, this is kind of a iteration of the spectral efficiency. So again, the same spectral efficiency of Axient digital microphones. You notice that with narrowband, there is kind of more opportunity for intermod, right? So, which is why we coordinate with 350 kilohertz channel-to-channel spacing. So that is another difference between narrowband versus wideband. And then this is basically, again, kind of the spectrum view of that information where you can, squeeze 17 frequencies in a 6 megahertz TV band. And again, to the broadcast folks out there, right, that means 34 mono channels of narrowband inside a 6 megahertz TV. All right. We also introduced a third transmission mode called analog FM. And so a lot of the sales folks kind of joke around that this is your PSM 1000 with your show link and your digital inputs, right? It's just another narrowband alternative, especially if you have artists that are just can't negotiate on the amount of latency, right? We offer 1.29 milliseconds of latency with this transmission mode. There's some limited backwards compatibility with PSM 1000 and the 900. When you're operating with analog FM enabled, there is an advanced menu item called Legacy Sync. So you'd be able to send channel name and frequency to PSM 1000 and PSM 900 body packs, right? So again, this is just another tool in the toolkit, especially if your production demands the lowest latency performance. Okay, so I covered 3 out of the 4 here. The last one I'll mention is point-to-point mode, which is basically the ability for the transmitter to act as a Axient digital standard microphone transmitter, right, to send high-quality long-distance audio to any Axient digital microphone receiver, right? So this is something that will be available in a future firmware release, so just be aware of that. And so that kind of rounds out the 4 levels of future-proof. Again, I also want to caveat that we are kind of still in the middle of this transition to WMAS globally, so the available transmission modes will be regionally dependent. Okay, so I covered transmission modes, right? So that's one of the 3 RF parameters. The second RF parameter to determine when selecting an operational preset is this new feature we're calling spatial diversity, right? And this is a feature that's only available for narrowband and wideband digital transmission modes, right? This is the concept here is finally being able to deploy 2 transmit diversity antennas on the rack side of this system, right? Each transmit diversity antenna is actually sending an identical signal on the same frequency to mitigate multipath interference, and also to easily support separate zones, right? So this is something that's only possible in the digital domain. In the past, people have used passive splitting techniques, right, which can be quite challenging to implement successfully, right? Because in a single antenna setup, right, if you're passively splitting that signal, though that RF bounces off of walls, off of objects, right? And if they hit at the wrong place at the wrong time, it creates a signal fade, right? And so passive antenna splitting could cause more opportunities for that phenomenon. With spatial diversity, this system doesn't care, right? It's demodulating. It's basically demodulating and decoding two streams of information simultaneously, and the body pack receiver is actually able to decode that information. So when you combine that with the fact that the body pack receiver is also true digital diversity, right, meaning two separate receive paths that gets digitally combined, right? We're talking about aggregating 4 total RF paths, right, to get the best possible quality of RF signal. So here's just kind of like another visual to kind of explain spatial diversity, especially as it regards to reinforcing your coverage, right? Again, finally, you have a transmit antenna technique, right, where you can use multiple transmit antennas, and it really helps in terms of, again, multipath interference, right? When you have that one signal, right, that one signal reflects off of walls, off of objects, and then there's challenges with like LED walls, for example, right? So being able to have 2 transmit antennas that are physically distant apart, same as you would with Axient Digital microphones, right? I don't imagine anyone in the wireless microphone land ever reverting back to a single antenna setup, right? You're finally able to overcome objects, overcome body blocking, right? And finally being able to get rid of, these really fast wispies that happen, right? Just because, that's what happens inherently in analog FM world. And again, you can also use spatial diversity creatively to support separate zones, right? In broadcast situations, right, you could deploy spatial diversity to support 2 different physical locations. In this case, 2 separate studios, right? For the professional touring folks out there, right? If you have a challenging stage area where you have your main stage area and maybe like a faraway catwalk, right? Spatial diversity would help in those situations. Okay, one other topic I'll cover is kind of related to how the radio resources are used with spatial diversity, right? One of the benefits of WMAS in particular is that it offers a greater efficiency of the available transmitter radios, right? With narrowband, right, it's kind of your traditional use case, right? You have each radio has its own power amplifier supporting its own dedicated channel, right? With multi-channel wideband, right, you're only using one radio to support multiple users, right? And you still have access to the same amount of power amplifiers to help with RF output power, right? And so with those other radios being now available, you can actually use those radios for features like spatial diversity. So if you go to the next slide, this is an example of using spatial diversity with WMAS, right? With 4-channel wideband, for example, right? You can have 2 radios supporting 4 channels, right? So with WMAS in particular, you can use spatial diversity without any loss in channel count, right, per transmitter, right? You could also use spatial diversity with narrowband, but that would reduce your channel count by half because it needs double the amount of radio resources to accomplish, right? So with spatial diversity, you need a radio for your first spatial diversity copy and a second radio for your second spatial diversity copy. So with WMAS, we can do that without losing channel count. With narrowband, you do reduce half your channel count. So that's just something to keep in mind, right, when choosing an operational preset. The next topic I'll cover is just like digital versus analog FM. Again, right, we have both wideband and narrowband versions of digital that all come under 2.9 milliseconds of latency. Spatial diversity does not impact latency at all, right? So our latency is consistent across the board. The only time latency changes is if you're specifically operating in analog FM mode. at 1.29 milliseconds of latency, right? So what you still get with analog FM is access to show link, right? So you're able to see battery life, you're able to see your headphone connect status, the volume position, right? All of these things that are normally not available once you give that pack to the talent, right? But you do lose things specific to digital RF, right? Things like encryption, spatial diversity, the new amount of spectrum efficiency that's associated with digital RF, right? That is specific to digital in the digital wireless domain. So, okay, we covered transmission modes, we covered spatial diversity, and so that third last parameter that we have to think about when selecting an operational preset is internal RF combining, right? Each transmitter offers a capacity to combine antenna outputs to a single output port, right? And the primary purpose of this is to reduce the amount of external combiner hardware for larger IEM setups. But one thing to keep in mind is, due to global regulations, RF output power is reduced to a maximum of 20 milliwatts when internal antenna combining is enabled. Part of this is just global regulations around how much intermodulation can occur directly from the transmitter device itself, right? But that 20 milliwatts, right, in a lot of situations, for some regions, that's already the max, right? And for other places, right, 20 milliwatts can get you quite far, especially if you have things like spatial diversity enabled, right? So it's kind of up to you to decide whether you need, do I need more RF output power, or do I want to enjoy the convenience of internal antenna combining? And to kind of discuss a little bit more about the convenience aspect of it, if you go to the next slide, this is a couple of examples of externally combining for narrowband signals, for example, right? With a typical setup without internal antenna combining, right? 2 quads would need its own dedicated 8-port combiner, and you need 8 separate RF cables, right? This is kind of what people are used to, right? But with internal antenna combining, right, you have more configuration options, right? You can plug in more transmitters into your 8-port combiner, right? Or you might not need a big fat rack combiner at all, right? You might go for a smaller 2-to-1 combiner to support 8 channels, right? Those same 8 channels, or you can leave the combiner altogether and just plug in 2 antennas directly. Again, a topic that I kind of want to hit home here is that with digital wireless, you don't need to combine as much, right? You could have more direct antennas without the concern of intermods, right? In the past with analog FM technology, right, we've always pointed out that you want to combine your RF as almost all the time, right? Because of those concerns around intermods and making sure it doesn't hit your wireless microphones, right? With digital wireless, this isn't as much of a concern. So there's more flexibility in terms of your external combining options. All right, so let's finally take a look at each of the individual operational presets. So, ultimately there's kind of 6 total combinations, right, that are similar to each other, and I'll kind of go through each one by one. So the first one is just traditional narrowband, right, which is available for both digital and analog FM. This is kind of how people are used to, right? People are used to having a dedicated RF output power per frequency, and that option is totally available. This would kind of be the mode if you wanted the most bang for your buck in terms of RF output power. This would be your way to do this, but it requires more external combining. Speaking of combiners, if you head to the next slide, I do want to point out that new combiners are required for Axient Digital PSM, right? We can't reuse the PA 8-to-1B or the PA 4-to-1B. And the reason for this is kind of twofold. First, the digital RF is much more dynamic in range. And so in many cases, that new digital RF could very well clip, your active combiners. And then additionally, both of these passive combiners are optimized for the new transmitters because it can communicate backwards to the transmitter to compensate for passive signal loss where available. When we're combining narrowband, right? Again, it's very similar to combining traditional analog FM systems like PSM 1000. I will say when comparing this with the PA 8-to-1, like there's no built-in 2-to-1 combiner. So if you wanted to combine two of these 8-port combiners, you would have to use a AD 2-to-1 to do that. However, right, combining more than 4-to-1 is generally not recommended for digital transmission modes because you end up starting to lose your total RF output power, right? We can only compensate so much to a point. And this is why I kind of left these two diagrams, right? Your left diagram is kind of your traditional 8 channels going into a single combiner, right? But you could, like, some of you could benefit from using a second antenna and spreading those frequencies across those two antennas for greater RF output power. So that is something to consider when configuring systems and optimizing for the long term. And then we have narrowband combined, which is the internal combining version of narrowband, right? So you have multiple frequencies that are then internally combined to a single RF port. The dual would then sum into port A. So yeah, so that's narrowband combined. And so how would you externally combine this, right? So again, internal antenna combining offers the convenience of reducing the external combiner hardware required, right? If users you can have 4 quads, which is 16 channels, like not even occupy half of an 8-port combiner, right? And that's quite impressive, right? One question I typically get is why didn't you create a rack combiner with 16 RF inputs, right? And then part of it is because we have both WMAS technology and we have internal antenna combining technology where you don't need as many ports, right? You have options if that's something that interests you. Then there's narrowband with spatial diversity enabled, right? When using spatial diversity, one thing I do want to always drive home is, be careful about where you're plugging your antenna cables to, right? We had to choose kind of the plumbing of our transmitters. And so with spatial diversity, right, the first frequency with spatial diversity is coming out of A and C in this case. And with channel 2 on a quad, it's coming out of B and D. So just, be careful. Sometimes people assume A, B, C, D, right? And this diagram exists as part of the selection, right? So you'll know right away. And on the back of the transmitters, there's also LEDs that light up to help you out in saying, hey, these are the antennas that are active, as a reminder, right? And we'll kind of have future updates in the firmware to try to make it as obvious as we possibly can. Okay. So when we're combining this, spatial diversity, especially with narrowband, right, you get the benefits of having 2 transmit diversity antennas, and then you also get the benefits of the greater RF output power of narrowband, right? So narrowband spatial diversity is kind of our best performing RF operational preset available, right? However, the trade-off here is that one, you reduce the channel count, right, per device. So each quad device, for example, is a 2-channel device, right? And it occupies quite a number of RF ports, right? So in this example, right, we have 2 quads supporting 4 stereo channels into an 8-port combiner, right? So it's not the most efficient use of space, and it's a lot more cables. But if you wanted the most robust RF possible, this would be your option, right? So yeah, something to keep in mind. And another guiding principle of spatial diversity is just making sure that you don't accidentally combine the spatial diversity signals together, right? Because that would completely defeat the purpose of spatial diversity. And then we have a narrow band spatial diversity combined, right? And this only applies to the quad transmitter because the quad transmitter has 4 radios to support this, right? The dual doesn't have enough radios to do this. So what that would look like in terms of externally combining on the next slide, right? You would have, in this case, right, you could support up to 8 channels on a single 8-port combiner. So this kind of helps with the space aspect of things, right? Without internal antenna combining, that smaller diagram to the left, right? You need double the amount of external combiners. So something to keep in mind. Next is multi-channel wideband, right? Which is kind of our WMAS mode, right? And you notice, right, in this case, sometimes people think this is internally antenna combining, and it's not. It's just the fact that we're only transmitting one frequency, right? We're only using one radio for either 4 or 2 channels, and that's just coming out of port A. Right, and so internally combining is fairly simple, right? It's just one port of each transmitter device going into a port on the 8-port combiner. So supporting up to 16 channels only takes up half of an 8-port combiner in this case. Then there's multi-channel wideband with spatial diversity, right? And again, be careful about your RF outputs, right? So on the quad, spatial diversity with WMAS is going to come out of port A and D, right? On the dual, since there's only 2 ports there, it's going to come out of A and B. So just again, be aware, double check your cable connections, that making sure you're hitting the right point. And this is important because even if you have only one antenna connected with spatial diversity enable, it'll still work, right? But it won't work as well as when you have that second antenna cable, right? So if you're ever troubleshooting and it seems like spatial diversity isn't working as well as you thought it would, double check your cable connection. Maybe you didn't plug that second antenna. And then in terms of how this looks like from a external combining standpoint, right? With the 8-port combiner in the 2x4-to-1 mode, you can support up to 4 quads or 16 channels of WMAS with spatial diversity. The last topic I'll cover is kind of a common question that I get all the time is like, which operational preset should I choose, right? And so there's kind of a decision tree here. Long term, right, when WMAS is more available across, globally, we believe that the best starting place is 4-channel wideband with spatial diversity, right? Because for us, it offers the best balance of RF performance, and spectral efficiency, right? It reduces the number of frequencies on air, and it provides that tool to mitigate multipath interference, which can get in the way, right? However, for regions where WMAS is not yet available, or if you're looking for greater RF output power for line of sight distance, right, narrowband would be your tool, right? If you need the lowest possible latency, use analog FM or analog FM combined. And if you need the best possible RF for any mission critical events, right, that narrowband with spatial diversity would be our recommendation. So the last thing I'll cover in regards to WMAS is one of the things I want to hit home is the fact that, like, even if WMAS is not immediately available for your region, the hardware is fully capable of that WMAS, right? So what I want to make clear is that this is a very future-proof product, right? When WMAS becomes available for your regions, we will issue a firmware update immediately, which would then unlock those operational presets that include multi-channel wideband. All right.
All right. That was awesome, Sergio. Thank you for all that information. I'm going to bring Jason and myself back on the screen. And it is, I got to bring myself on the screen. There I am. Hey. All right. And I'm going to get rid of this so they can see our faces, large and in charge. And we will dive into questions. So if you have a question, get it typed in. Looks like we've got plenty of time for them. So we're ready for questions. And starting with the first question, very good one. Will Wireless Workbench 7 have any new updates to integrate new features of the new devices?
Yes, so there will be a new version of Wireless Workbench that will include support for Axient Digital PSM. One of the features that we're particularly excited about is the management of unlinked portable devices for Axient Digital PSM specifically. What's great about the ShowLink ecosystem with Axient Digital PSM is that for the first time, you'll actually be able to remote control and monitor unlinked receivers, right? So that is something we're excited to introduce to the world.
Fantastic. Next question. In a touring case scenario, will it be easy to swap from narrowband to wideband? Let's say you need wideband in Chicago and the next day you're in Montana and can use narrowband. How easy is it to swap the system? And then, of course, will it be available to do so on Wireless Workbench 7?
Yeah, so in this case, right, there's no swapping of systems required, right? You'd simply choose the operational preset that includes narrowband operation, and you hit the ground running, right? The the thing I want to remind people is that it does erase your linked registrations, right? So if you do need to change operational presets, either based on a different environment or experimentation, right, you will have to relink those portable devices.
Okay. When using spatial diversity, do you have to use a left spun helical and a right spun helical, or can they both be in the same direction?
So they could be in the same direction. I think in this case, the system doesn't care. The helical's job is really to help with the polarization issue, right? Depending on the orientation of the body pack, and that doesn't change with spatial diversity.
Okay. How does Dante or AES inputs affect the latency?
Okay, so in terms of latency, right, that is consistent across digital, which is 2.9 milliseconds of latency, and analog, which is analog FM. The only other caveat I'll add is that Dante does add its own amount of latency, so double check your Dante settings. I believe Dante has configuration options to reduce that to 0.25 milliseconds. But with AES and analog, right, they're essentially they do not add any additional latency.
Great. Next question: can multiple body packs be synced to the same transmitter and/or mix?
Yes. So the linking paradigm that we're shipping initially has up to 8 receiver slots. So you can have up to 8 portables follow the transmitter frequency, right? But you could also sync a body pack without linking altogether, right? And you can have unlimited portable receivers listening to the same transmit audio. So this is something we kind of want to explore. This is our first iteration. There's things we're going to learn along the way, but this is how it's going to work at launch.
Okay. So say you're using a quad when using internal combining in analog FM mode. Will 20 milliwatts of power be for each narrowband transmission?
That is correct.
Okay. A question from me. So I know in the past we've been able to use mono mix modes on, and will that be an option as well? So if you don't need stereo mixes, you could potentially get up to 8 mixes using mix mode on Axient Digital PSM?
That is correct. We will offer mix mode, and that's really, if a person wants to kind of mix for themselves between 2 mono sources. But we also added a convenience feature where you can simply just change the mode to stereo left or right, and I think that's a bit of a faster operation, especially for the broadcast folks that just want to select the channel. And so we let our users choose between how they want to set that up.
Sold, Sergio. Just ship it to me immediately.
The stereo separation is significantly improved on this product as well. So way less crosstalk between the 2 channels.
Love that. You just sold me again. Gosh, guys. All right, next question. How will this change the RF environment in large-scale festivals? With tours coming in that are still analog, will RF coordinators be able to use one system to coordinate digital and analog systems from multiple users?
Yeah. So Axient Digital PSM is meant to be a very good RF neighbor, right? We're not introducing RF carriers that take up huge swaths of spectrum. And in any case, right, in terms of RF coordination, right, our wireless software will integrate with this new product as well as our previous products like PSM 1000. So there's, I believe, as long as, especially when you're in the Shure ecosystem, there's nothing stopping anyone from coordinating the new and old products together.
Great. When using a wideband carrier frequency, how do you tell the pack which of the 4 mixes to listen to?
Yeah, great question. So that's simply one, the syncing paradigm will take care of that for you. But you could also manually tune body packed receivers. In that case, you would have to select the transmission mode, right? The frequency, and you could choose the sub channel parameter as well.
All right.
Yeah, within each wideband carrier, there's the properly allotted amount of subcarriers. So a 2-channel would have subcarrier 1 and subcarrier 2, and a 4-channel would be 1 through 4 subcarriers. Those all have independent audio mixes, and that's how you decipher which one you sync to.
Fantastic. All right. I think that wraps up all the questions, but lots of great questions. Thank you for that. If you do have a question that we somehow missed or that pops into your head, you can go. Oh, wait. Speaking of one that just popped up, here's one that just popped up. Here we go. For the mode that has all 4 signals on a single carrier, so that would be wideband, digital, and 1 antenna, it seems like the other 3 radios are just sitting there going to waste forever. Will there be a model that has just 1 radio at a lower price point for users that don't need all the extra diversity options?
That is a great question. We're always working on new and exciting things. And so we are very interested to see how this WMAS technology scales in all types of directions, right? While we have time, I will introduce the fact that well, another thing you could do with those free radio resources, and something that we're going to explore in a future firmware update, is the ability to scale up your channel count, right? So you could expand your channel count up to 16 with the quad, because each radio can do 4, so 4 times 4 is 16, or up to 8 with the dual with its 2 radios. And so that is something that's coming into the future. However, again, as you noticed, right, spatial diversity offers a lot in terms of RF reliability, right? So that does use up double the amount of radio resources. So really, like, the initial channel count is kind of the most flexible in terms of like the greatest RF performance. So there's just something to be aware of. But if you're in a stable environment, right, you might not need all those bells and whistles, and so channel expansion at a potentially lower price point might be of benefit for specific users.
Okay. Next question. Can PSM 900 and PSM 1000 packs be connected in analog mode?
It can't. So we specifically added a separate IR sync function, right, that we're calling legacy sync when the transmitter's in analog FN mode, and that'll simply send the channel name and frequency information. We had to separate it as a separate IR function because it's using completely different IR protocols. And so that's the main reason why we separated it. But there's a way to kind of get multiple body packs online using an analog FM Axient Digital PSM transmitter.
If the environment has a lot of cellular phone users, do they interfere with the RF of the receivers?
The answer to that is potentially yes. I mean, it depends on phone versus Wi-Fi. I kind of would need more information on what's actually going on. But in any case, it is using the Zigbee protocol. And so there is an option to use a specific part of the Wi-Fi with Zigbee that is outside of the typical 2.4 that other devices may operate in.
Okay. When comparing sound, what are the noticeable audio differences between the P10R Plus and the new Axient Digital packs?
Jason, you want to take this one?
Yeah, sure, absolutely. This, you could, if you're familiar with the analog to digital transformation from Axient Digital to Axient Analog, there's a lot of similarities there. Some of the greatest improvements we see from an in-ear perspective is the noise floor in the digital modes is incredibly silent. We've actually been told it's too silent, and that end users on stage are concerned the pack's not on, which is kind of hilarious and awesome at the same time. So really quiet noise floor, increased stereo separation, as I mentioned before. A lot of the pain points that we've heard from analog IAM users in terms of the whishes and the pops and the crackles, that's truly the benefit of digital audio, and all of that is essentially gone, and you have an incredibly clean sound. There's an improved sound profile in Axient Digital PSM that is significantly more flat than analog PSM was for a number of reasons. So more flatter, cleaner frequency response, lower noise floor, and better stereo separation.
Awesome.
Yeah, the other thing I'll add is because this is a digital wireless system, right? The audio quality isn't impacted by the RF, right? There's no relationship between the signal to noise and the digital audio. So what you get is clean, consistent audio all the way until the end of range.
Okay. I'm not sure how this next question you gents will probably understand better than me. Will you be speaking with the sound-based folks about adding new presets to Coord?
That is a good question. as of right now, we will not have that third-party control available at launch, but that is something that we are considering as a feature.
Great. Next question: can you sync a digital pack without ShowLink?
Absolutely, that would happen over traditional IR syncing.
Great. When talking analog versus digital narrowband, how would the range suffer between the two if running at the same power?
So I guess with total power being equal, you would have greater distance with narrowband because you don't have this concept of shared power. However, right, if that game sort of changes if you enable spatial diversity, right? One of the things that's kind of counterintuitive with spatial diversity is that you can actually get better range performance and better reliable RF with spatial diversity at a lower RF output power compared to a higher RF output power without spatial diversity, right? And that is something that's going to be new for people. But it's great because, right, you can get the same amount of performance with less RF output power, right? Which means, especially in like festival situations, right, you can get away with perhaps multiple systems at lower power that aren't competing with each other.
Okay. What will the output power limitations be with the future increased channel counts? Would they decrease to something like 5 milliwatts per mix?
So we are still learning more about RF output power with future operational presets that would include scalable channel counts. So I don't have an answer for that today, but as soon as that information is available, we will share it.
Great. Okay, I think that got through that next wave of questions. So I'll continue on and say if you do have questions about this or any other topic or something that pops up in your head, you can always go to shure.com/contact. Once again, that is shure.com/contact. You can fill out the form there to be connected with our fabulous support team. They can answer questions across a wide range of audio topics, including the one question that is not related to today's session that somebody keeps popping in, which is what is the best mic for streaming? We do have many other webinars about streaming mics, but I will just, since I'm here, say you can use the MV7 Plus, which I'm using right now. Very easy plug and play. We also have the brand new MV6, which is also great. Jason there is holding, that's the SM4. Thank you. I was about to say the wrong number, which is also a fantastic brand new mic in our portfolio. But lots of great information about streaming mics at shure.com. So thank you so much. Oh, wait, let's see. More questions. And what is the best mic for live streaming? Okay, I hope I answered that question. All right, everybody. Thank you so much for joining us today. We hope you're as excited about Axient Digital PSM as we are and as I am. And we hope to see you on our next webinar. Have a great day.
Thanks, everybody. See ya.